Hi guys, hope everyone is doing well. We're going to start a new unit today called functions. And today we're going to spend our lesson making sure we understand what a function is and what it isn't. So a function, essentially what it is, it's a relation between x and y, but it has special properties, and that's exemplified in the ordered pairs, the graphs, the table, and the mapping. So we're going to be using two words a lot this lesson, and that's the domain and range. What domain is? Domain is the inputs, or we can say x values. The range is the outputs, or the y values, whatever you're familiar with. So one way a function can be represented is through ordered pairs. So a set of ordered pairs like you see over in the example column. And the way we know if the ordered pairs are a function is every x must be paired with only one y. So you can have a set of ordered pairs where there's x's that have two different y's, but that's not a function. That's called a relation. So the x values, in other words, the x values cannot be repeated. So the reason this example here to the right is a function is because if you look at these x values, 0, 1, and 2, they're not repeated. There's only one of them, so that means we have a function. Each one of those x's goes to exactly one y. In a graph, we're going to use something called the vertical line test. And I'm going to explain what that is in 1 minute. And what the vertical line test is if you draw a vertical line at any point in your graph, any point, it only passes through that line once. So for example, if I draw a vertical line here, it only passes through at this point right here. Pick any other spot. So say you pick down here, only goes through once. Since it only goes through once, the vertical line test tells us it is a function. If we have a graph where when you draw that vertical line, it hits that graph more than once, then your relation is not a function. The third way you can see a function is through a table. And the same exact rules as ordered pairs, it's just a different method of seeing the numbers. So again, each x value can only be paired with exactly one y. Again, the x values may not repeat. So the reason this table here is a function is let's take a look at these x values. We have -1, 1, 3, -5, 2. None of those x values repeat, which means every x has exactly one y, so it is a function. Mapping is a little bit different. You may have not seen this before. What it is you have two circles. The circle on the left is your x's, and the circle on the right is your y's. So with mapping, every x value, again, must be matched with one y. And the x values, there's an arrow coming out of each x value going to the y. In order to be a function, x values cannot point to more than one y. So in this example, if we follow the arrows, then each of these x's goes to one y. Doesn't matter that they both point to 7. There's only one arrow coming out of each x value. So now we're going to do some examples. Let's look at A. We have another set of ordered pairs. We have to figure out if this is a function or not and why. So this here, let's look at our x values. That's how we determine if it's a function. So we have -1, 3, -2, -5, 4, -4. None of the x values repeat, so that means each x has exactly one y, so it is a function. So we're going to write that. Function because, I'll use b/c, each x is matched with exactly one y. In other words, the x values don't repeat. I'll put that underneath. Our second example, we have a table, part B. And again, we need to look at those x values and see if they repeat. So we have -1, 1, 3, -5, 2. So since those x values, again, do not repeat, that means that we have a function. And our explanation is going to be exactly the same. We say function because each x is matched with exactly one y. In other words, x values don't repeat. Let's look at part C. Here we're given mapping, and with mapping we have to look at the arrow, so where everything is pointing to. So 5 is only mapped to one thing, -3 maps to one thing, 1 has one arrow coming out of it, but 6 is our problem guy. 6 has two different outputs. 6 has an arrow going to 2 and 6 has an arrow going to 5. So that tells us that this mapping is not a function. So we say not a function because has two different outputs, or two different y's, whatever way you remember. All right, and last but not least, we have a graph. With a graph, we use that vertical line test we talked about. So we can draw a vertical line at any point here, so I'm going to pick right here. And that line only has to go through the function once. If it goes through more than once, then it is not a function. It goes through the graph only once. So here we notice it goes through right here and right there. So that tells us that that graph, that relation is not a function. So we're going to say not a function. Because each x or we can say there is an X with more than one output, because not every single input has to have multiple outputs. It just has to be one. So we can say, because there is an X, that matches to more than one Y. And that's it. These are your examples of functions and relations. Have a lovely day.